In this example, we have a 10-foot ladder that is leaning against a wall. If the top of the ladder slides down the wall at a rate of 2 feet per second, we want to find out how fast the bottom is moving along the ground when the bottom of the ladder is 5 feet from the wall. One of the first things we want to do is draw a diagram to help us model the situation. So we've got our 10-foot ladder leaning against a wall, and we're going to let X represent the distance from the wall to the bottom of the ladder. We'll let Y represent the distance from the ground to the top of the ladder. And then, depending upon your diagram, you can go ahead and use that diagram to help you create an equation to help you model the situation. So you'll recognize that we have a right triangle here. We can use Pythagorean theorem and create the equation x squared plus y squared equals 10 squared, which is 100. And now let's go ahead and take a look back at our problem, and we'll work to identify the components that were given to us. The top of the ladder is sliding down the wall at a rate of 2 feet per second. So that's going to represent a change in the y values with respect to time. So dy dt will be 2 feet per second. The fact that the ladder is sliding downward, we can go ahead and make this a negative. We want to know how fast the bottom is moving along the ground. So we're going to be looking for dx dt when the bottom of the ladder is 5 feet from the wall. So they're giving us an x value of 5. We'll need to calculate the y value at this time point. So let's go ahead and do that first. We'll use that equation x squared plus y squared equals 100. And let's go ahead and plug in the x value of 5. That'll give us 25 plus y squared equals 100. If we subtract the 25 from both sides, then y squared will be 75, which means that y is the square root of 75, technically the positive or negative square root of 75. And we can rewrite this as radical 25 times radical 3, which will simplify to 5 radical 3. And we'll use the positive value since that's representing the distance from the ground up to the top of the ladder. So now let's go back to our equation, x squared plus y squared equals 100. And we're going to go ahead and take the derivative. So we've got 2x times dx dt plus 2y times dy dt. And the derivative of 100 is 0. Now we can go ahead and divide everything by 2 just to simplify our equation a little bit. This will give us x times dx dt plus y times dy dt equals 0. And we can go ahead and plug in each of the values that we know, or at this point, we could also go ahead and rewrite this so that we're solving it for the component that we need. So that choice is up to you. You can do whichever you like. I'm going to go ahead and rewrite this and solve this for dx dt since that's what we're looking for. So I'll go ahead and subtract the y dy dt from both sides. So that'll give us x dx dt equals a negative y dy dt. And we'll go ahead and divide both sides here by x. So dx dt will be negative y over x times dy dt. And so let's go ahead and plug in the values that we know. Our y value was 5 radical 3. So we'll have negative 5 radical 3 over our x value was 5. And dy dt is a negative 2. Right? These 5s are going to divide out to give us a 1. And we can simplify. The two negatives will make it this a positive, and we're going to get 2 radical 3. That is our exact value. If you want to go to your calculator and get a decimal approximation, I'll take this one out to 2 decimal points. This is approximately 3.46. And make sure you put your units on it. This would be feet per second.